autonomous status in 2019. It was promoted by KPR Charities, you know, KPR Mill public sector undertaking. We have 12 UG programs, 4 PG programs, 10 doctoral programs, 4,000 plus undergraduates, 60 plus postgraduate, and 215 PhD scholars at the moment, both full-time and part-time. And we are ranked 51 to 100, sorry, 51 to 100 in innovation ranking and 101 to 150 in engineering category. We are declared Great Place to Work, certified in 2023. We are 801 to 1000 band of impact rankings time, the impact ranking. Just want to touch upon what is sustainable chemical engineering. Do you all know that we are releasing around 0.91 to 0.95 kilogram of carbon dioxide every unit of electricity that we consume, that is produced and consumed. Every unit, 1 kilowatt hour is 1 unit, that is what we pay for, that's the unit that we pay for. And we are generating, during generation of this power in thermal power plant, we are releasing 0.91 to 0.96 or 95 kilogram of CO2. You can imagine the amount of CO2 that is being released when you are using in industries megawatts and gigawatts of energy. What's sustainable chemical engineering? We all know chemical engineering is all about producing a useful chemical product by utilizing the raw materials, whatever that is available nearer to you, or you import from other places, using the forms of energy that is available, and you convert into some useful products in an economical and safer way. That's what we were taught when we entered into chemical engineering. Now, that chemical engineering has to become sustainable now. Sustainable, when we talk about sustainable, we need to look at every place in the supply chain, right from the raw material procurement until it is utilized and the waste that is being generated, everything has to be looked at. Creating a process that utilizes the materials efficiently. That means you are not releasing any waste material and regenerates them to have both an environmentally and economically sustainable process. When we talk about sustainability, we talk more about environment. Chemical engineers are also involved in developing new materials as well as new processes from sustainable sources aimed at reducing waste without compromising on performance. We never want to compromise on performance, but at the same time, we need to make the process is efficient. And in other words, I can say efficiently transforming raw materials into useful products, developing new materials from sustainable resources. Now the resources it should be sustainable resources, not that the one which we are depleting the resources. Generating clean energy, capturing emissions, and removing contaminants from the air and water. It captures everything. One, it says raw materials which are sustainable into useful products. We are getting into new materials from sustainable sources, and you're talking about clean energy, and you are not supposed to emit anything, and if you are doing so, then you must capture them, okay, and remove any contaminants that you may be releasing into air and water or even land. Talking about environmentally sustainable, in the operational point of view, I would consider if your process is generating less waste, we are more sustainable. There is nothing like we are completely sustainable. It's all relative, subjective. If you generate less waste, you are better in terms of sustainability. No pollution or emissions, gas, liquid, or solid. One example in oil and gas industries is CO2 capture, storage, and utilization, and use of renewable energy sources. I said if you are using electrical energy from thermal power plants using coal, you are releasing so much of CO2, and where do you reduce this? You are looking for alternative energy resources, and alternative energy resources could come from hydroelectric, wind, solar, biomass, that is renewable. Okay? Hydrogen, algae, etc., and renewable raw materials such as biomass. Of course, when the chemical engineering was developed, the processes were developed with the available raw materials and that were depleting, but they were more concentrated. It was easy for you to design a plant and then convert them into useful products, whereas if you are looking at alternative raw materials, they are not as concentrated as what we used to get. And that is where our processes has to become more in terms of conversion and so on and so forth. And we also talk about circular economy. Sustainability comes with circular economy. Whatever that, as chemical engineers, that we produce, those products after use, the products could be used, reused, and used efficiently. You can, if you are not using it, allow it somebody else to use it, share it, lease it, whatever form of usage. And once it's beyond its usage, its lifetime, then the same thing has to come back into the feedstock that's completely recycled. Recycle, when we chemical engineers, we talk about recycle, we only talk about unconverted reactants getting recycled into the plant. That's what we think. Recycle here, it means that the product goes into the market and it's being used for several years, and once its lifetime is over, the product's lifetime is over, then you collect back and start using as a feedstock with whatever processing that you need to do. So in this way, the life cycle of products can be extended, and it obviously reduces the fresh raw material requirements as well as all those associated emissions and energy requirements. I'm taking this 12 principles of green chemistry as the basis for developing sustainable chemical process. I just read out, it is all there in the, you just Google it, you will find these 12 principles of green chemistry. One is prevention of waste, never produce waste. Atom economy, what it means, what atoms of reactants are incorporated into the final desired products and what atoms are wasted. Okay? So look at what atoms are used that goes into the final product and what is not used. Less hazardous chemical synthesis, designing safer chemicals, non-toxic, non-hazardous, safer solvents and auxiliaries, even solvents that you use to be safe. Design for energy efficiency, which I will talk a little more on this afterwards. Use of renewable feedstocks. I talked about biomass and others. Reduce derivatives, don't go for too much of derivatives where you are adding processes and you are adding energy requirements. Catalysis. Catalysis is one area where it can help you improving your conversion and yield. And design for degradation. Some of those plastics that we use, they are non-biodegradable. You put them on earth for ages, they don't get degraded. So try to produce products which are degradable. Okay? Real-time analysis for pollution prevention. Yes, we are in Industry 4 era. We need to analyze everything on real time, and we need to see whether we are crossing the safer limits of operation or are you producing any toxic or hazardous chemicals. And inherently safer chemistry for accident prevention, that the chemistry also changes when your operating condition changes. If you are not controlling your operating conditions properly, you are moving into another region where your reactions may change and you will produce different products, chemical products that may not be safer. So based on which, I'm just going to touch a few points for want of time. One is energy efficiency, how we improve energy efficiency in the plants so that you can make your process or the plant sustainable, chemical plant sustainable. One is your objective is always to reduce specific energy consumption. Specific energy consumption is the energy consumed per ton or per unit of product produced. There are different ways. We always talk about energy integration. We try to recover energy from the end of the process or from the hotter sections of the plant into the colder sections. Energy recovery and utilization, energy monitoring. Energy monitoring, when you talk about energy monitoring, this is a very, very essential area in operation of your plant. Design is one thing. You can always design a plant with all that energy recovery, energy integration techniques. And end of the day, when it is being operated, you find that energy is being wasted somewhere, energy is being lost somewhere. How do you know that? So monitoring is very, very important when it comes to ensuring energy efficiency all the times. The energy farms in chemical industries, oil and gas industries could be either coming from electricity, less of electricity, more of fuel, and steam. And you know steam, when you talk about steam, the generation efficiency is only about 80 to 85% in the boilers. And distribution losses, utilization can come up to 60 to 90% only. I did one project for an ammonia plant in Malaysia, and I found that the steam utilization efficiency was only about 52%. And the plant was losing so much of energy for so many years. When we identified that the steam is being lost, and we identified this is the place that you're losing, and next turnaround they changed all their steam traps, and the energy efficiency went up to 95%. Can you imagine? In an operating, large-scale operating plant, the energy efficiency of steam utilization efficiency going from 52 to 95. Because there was no energy monitoring system in place, they didn't know that it was 52% only. And they found a huge profit by changing all the steam traps. That's just a mere change of steam traps, nothing. They didn't even re-insulate the steam pipes. Process efficiency, one has to always think about increasing the yield, increasing selectivity. The moment you increase your selectivity, you are producing more of the desired product and less of waste. It's two-way. Okay, you produce your product, which is desired, and at the same time, you're reducing your waste. And what can help you in increasing your selectivity is the right choice of catalysis. The right choice of catalyst can help you in improving yield as well as selectivity. I'm currently working on a project. I'm a consultant to naphtha reforming project. Naphtha reforming in refineries is either semi-regen or continuous catalyst regeneration CCR units, which are licensed by UOP. And these plants are, capex is very high, opex is very high, the energy requirement is high. They operate at temperature of 510 to 550, high temperatures, and pressures ranging from 6 to 35, and the operating cost is very high. And now we are working on a catalyst which is zeolite based, and we are able to get nearly, economically we are able to beat the CCR process with 50% of the capex. So that's how you make your plant sustainable, by reducing the energy cost and also by reducing the capex, because we are operating at low temperatures and low pressures, and therefore, and we are also in our process, we are also removing the recycled gas compressors and so on and so forth. Process intensification, as it was mentioned in this morning, process intensification is another area where you can always try to reduce the use of materials for manufacturing your pressure vessels, pumps, pipelines, and so on and so forth. It's not only when you are reducing your size of your plant, it's not only that you are reducing the capex. That's one direct benefit to you, is reduced capex, capital expenditure. But the indirect benefit is that you are not used some of the material that could have been used. And that material that is not used, you are not used the energy for processing that. You are not released any carbon dioxide out of that process. There are so many associated benefits with that also need to be accounted for. Very important aspect is also process safety. When you talk about sustainable chemical engineering, the sustainability can be completely lost if you are not operating your plant in safer operating conditions. This task takes the top priority in plant design and operation, and one unsafe incident is good enough to kill your plant. And I just quote a few examples, the Bhopal disaster in 1984, Chernobyl disaster, and BP's Mexico oil tragedy. And these are one of the major ones which everyone remember. But there are a lot of minor ones, and I have been associated with about 60 operating units of Petronas, and we do here, every week we will get one inspection report of some accidents, mishaps, fire, and so on and so forth, and how they close the cycle. Okay, and we are in Industry 4 era, and the Industry 4 era also can help you in improving your sustainability. And this is the opportunity that you need to make use of. Okay, one is you can look at alternative materials, cheaper materials, you can use less materials, you can try to design, develop a process that uses less energy and so on and so forth. Then the major benefits that you can bring at this moment, everyone talks about is digitalization, and using digitalization, what you can do, and there are a lot of benefit that you can derive it. Okay, once you start digitalizing, start collecting data, real time, and process the data, you identify where the process is deviating from the normal operating conditions, then it's easy that you can quickly recover and put it back into the right operating conditions and save the plant. Although we have all distributed control systems in, the distributed control systems normally operates at that temperatures. But when we talk about fault diagnosis, fault detection, fault diagnosis, these are the things that we can do with data that gives you the unsafe conditions which are about to evolve a day later or a week later. You can predict right now, so that you can make use of this information to prevent any untoward incidents. Digitalization initiatives has given you a lot of information about the plant, and advanced process control is one area where the plants are better controlled than just using the basic regulatory controllers based PI and PID controllers. Now you are able to make use of advanced predictive controllers where you predict in future. Our PID controllers are based on the information in the past, where we have deviated, when we have deviated, to how much, and so on and so forth. But the predictive controllers look at what input I'm going to give now, what will be the effect of this input on my plant output next 60 minutes, then I try to optimize my input so that I can stay closer to the operating conditions. So the advanced regulatory controllers also use data. Inferential control, feed-forward control, ratio control, they all use the data. And the most important one is the model predictive control, which is prevalently used in all the oil and gas, major or large-scale plants. Now the APC is part and parcel of all control systems in all plants. The other one is fault detection and fault diagnosis. This is a very good area, and I worked with in collaboration with Hitachi R&D, the main R&D. We worked on an industry refinery data, and we were able to pinpoint the time or the day at which your process started going out. We take the data, we do a big data analysis, do a machine learning. Okay, you are not taking one particular, we are not trending one particular information on temperature, flow, or pressure. We take everything in together, take a combination of that, and try to build a model, and the model gets developed, and you run the model in parallel to the plant, and the model says this is where, and when the data is given, and the software tells you that there is a change, there is a deviation. And we were able to, we took 3 years of data from a refinery, and then we analyzed all those incidences, and we were able to get 95% to 99% of that. We were able to say your plant was moving away. Then they look at their operational data. They say, yes, today we changed the crude, we changed the crude blend, crude slate, and so on. Operating conditions, today they reduce the load, all that conditions come. Okay, so there is too much in store for us to make use of the data in operating our plants. Then, of course, once you have your machine learning models, you can move into artificial intelligence. Artificial intelligence is going to be the technique that is going to be used in process industries. The reason, we do not have enough skilled manpower in industries to operate. 30, 40 years before, if you go into a refinery, you will see hundreds of operators opening the valve, closing the valve in every section. And nowadays, you can see that there is no less, or I would say 2 or 3 operators inside the plant, and the whole plant is controlled by the panel man in the control room. There are nobody inside. Only if the panel man says there is something wrong, can you go? Then somebody else goes. Okay, now a control valve is non-responsive, please go there. A pump is not starting up, please go there. Otherwise, you will not find any man, any operator inside a plant. So it's being operated. For your information, I just want to tell you, on the onset of COVID in 2020, I'm referring to a refinery in Malaysia. It's a Malacca refinery, Petronas Malacca refinery. You know, the moment on 17th when the lockdown came, the operators were not allowed to even travel. And this plant was not shut down, and they were able to operate it from their homes. All the engineers were connected through web, online. So they can monitor, sitting at home, they can monitor. So they were well prepared. So not necessarily you need to sit in the control room. Okay, and they operated so well. You know, operating a refinery at a full load is much easier to operate at 40%, 50% of the load. There are no fluids, there are no inventories, there is no hydraulics to ensure the continuity of the process. When you want to operate at low capacities, the challenges comes in. And the operating team managed the situation very, very well. So industries need to make use of data, pre-prepared for all that kind of situations. And of course, artificial intelligence, expert systems. I was talking about the less of skilled manpower in industries. People do not have that much experience. Even those operators or the technicians inside the plant are less experienced. And if there is a problem in the plant, they were not able to troubleshoot. They were not able to even identify what exactly is happening. The skill in industries is declining. And what can substitute that skill? What can substitute that skill is the AI. So what you need to do is you need to take the experience of all those experienced engineers, take their input, build an AI model, and the AI will tell you, connect it with the fault diagnosis. AI will tell you, this is the diagnosis, do this, do this, do this. You don't need a technician. And you certainly need this, and in my expectations, in less than 10 years, you will have AI running all the plants. I think that's where I'm coming to an end, and I would like to take some questions. I actually wanted to be short, and then I will take any questions from the industry, from the participants, please. Students, only in our country the choice, the priority for chemical engineering is less, interest in chemical engineering is less, whereas in other countries around us, the chemical engineering is the first preferred choice. I worked with University of Technology Petronas, and we used to take about 400 students in a year at 3 times, January, May, and September. And every time the chemical engineering branch gets filled, only after that other branches will start showing some interest. MNCs obviously pay a higher salary, and oil and gas definitely pays a better salary than other chemical industries. Petrochemical industries, oil and gas definitely pays better salary, and they also have better career progression. They have, if you take Petronas, they have a very clear career progression. This many years, you qualify this, you're moving. They have all, what do they call, technology readiness levels like us, like our product development. They have everyone, awareness, expert, and so on and so forth. You prove that you are an expert in that, you move up the ladder. Yeah, you are not stagnant. And one thing I didn't touch is economic sustainability. Of course, that is the every management looks at the dollar sign. End of the year, what do I get? Okay, I didn't touch on that. Make your process sustainable environmentally. Then obviously you can go for economics at a later stage. Any questions? We do not know the names of students. Please.
People say that in moon, the hidden reserve of helium plus is available. If you can bring that more to our Earth, plenty of energy we can get it environment free.
Okay.
What is your idea about that?
I'll send Professor Kannadasan to moon next time. I'll tell the project director of Chandrayaan 3 is coming to my institute on November 4th. I'll tell him.
Plenty of material is available. Just 1 kg of that material, the helium plus is, if it is brought back to our planet Earth, it can meet the energy needs of New York, New York City for 1 year. From 1 kg of material using fusion technology. It is completely environmental. That's why including India, everybody is why we are aiming for moon means to get back to material.
Let's see if we can have some way of bringing it back safely.
Only thing that moon doesn't have atmosphere. You dig it when it will fly away. You find some mechanism, you would dig it and you would process it and you would bring back the enriched material. And of course, you will get it. Then by another 5 to 10 years, and days are not far away. Our Tamil Nadu electricity board will say if you consume 1 unit of electricity, another unit will be free. Definitely will come. Not my time. Youngster time will be. Definitely will get.
Yeah, some keywords I didn't use here. One is nanotechnology. Okay, and another example that I can give you is the ionic liquids as solvents. Okay, we have been using solvents, which does the purpose 50% and remaining 50% doesn't. Whereas ionic liquids, you can synthesize, tailor-make your ionic liquids to do the job, only your job, nothing else. So that kind of studies you can make.
Hey, last operation, 3 questions. I'll ready ice cream, 40 minutes. Yeah, ice cream stall is there. Amul is there.
Who wants ice cream?
He will give ice cream.
Professor Chidambaram will give you one, I will give you one.
What is your suggestions if you want to make sustainability as a part of the curriculum? But I just want to understand on this perspective because you are in a position where you can influence somebody to put it into the curriculum, right? So from that perspective, because when we see the people, students, young engineers coming to industry, as I spoke on the panel, we, including myself when I am a student, we are not readily employable. Right?
Yes.
So, and a companies or whoever it is, they spend a lot of time and money, and of course, some people will continue, some people will immediately go away to some other lucrative jobs.
Yes.
Right. As of today, the core engineers are paid better, but it's not the same 15 years before when we came out. It could be equally worse than when you were coming out,
Yes.
right? Maybe we are far better than you, but it's good that people are recognizing just not computers or software, the core engineering is also equally paid. So people are coming into the industries
Yes.
now, right? But the big challenge what we see as a recruiter from my company side, right? The sustainability part of it, it's a buzzword now. Everybody will talk about sustain, but without clear understanding what it is. So if we need to have certain courses, at least an elective subject of sustainability into the curriculums, so that engineers can start feeling about it before they
Yes.
come. So what is your suggestion, or how do you want to put it?
Supreme Court lawyer,
Uh,
Supreme Court judge has announced that we cannot
Sustainability included in curriculum. I think most of the curriculum today has sustainability as an element. It's being included. I think I mentioned that behind my name is C. Eng. I'm a chartered engineer from Council of Engineers UK through ICME. And to get this chartered engineer and chartered member of ICME, you certainly need to prove that you know certain things. And also ICME accreditates your programs, and where they're looking at the depth and breadth of chemical engineering subjects, and sustainability is one of the elements. They will not accredit any program which doesn't have the sustainability elements in the curriculum. And most universities, as I know, they have included, and I think our curriculum at KPRIT, we do have. I think Professor Bala who's head of the department, is here. We do have, yeah. Yeah, autonomous colleges are free to change the syllabus, so we do have elements, and we are focusing more on UN Sustainable Development Goals at our institute. And he talked about salary as well. I want to tell you one thing for core engineers, not only for chemical engineers. Your salary may be low today. As you enter into the job market, you get into a plant, your salary is low. And then as you gain experience, as you become expert in something, your salary is going to go up. Okay? There is no retirement for you. Okay? If the company says you are to retire at 60, the next day there is somebody else to appoint you as a consultant. Okay? I am a principal and secretary for the college, and I am still a consultant to Transwater, Tanaga, Sundaren Bargad in Malaysia. Okay? That's where I am doing the naphtha reforming project. I'm a consultant. I used to lead the project while I was in Malaysia. So when I left, they said you should be there. Okay? So that what it means that once you have experience, once you have expertise, knowledge, know-how, the age doesn't matter. Even if you are 80, they will make use of it. Okay? Your value increases exponentially. Only the first 5-6 years you will find it's not moving anywhere. And after that, once you give a jump, it keeps going up. Whereas I want to compare with IT field. Okay? They are very agile now. They'll be able to adapt to any new language, new platform that is coming, quickly adapt and change it to anything. And then their salary is very high. And after 35 and 40, their brain starts stopping to work. They don't work that much as it was when he was 21, 22. And their value goes down. Okay? That is the reason why the IT field, the retirement is something like 45. People do not want to work after that because they cannot catch up with the changes in technology developments. Yeah, they earn a lot of money, they enjoy, but what do you do with the money?
Sustainability, sir. Again, sustainability.
Sustainability
we
is
can
not
earn
there.
even after retirement.
And you are sustainable. Until the last day, you can be employed somewhere, in some way or other. So make sure that you are not being paid low initially. You are actually, it's a preparation ground, it's an investment. You learn something, learn some techniques, understand the best practices, develop best practices, and you are above the curve. Yeah.
Thank you, sir.
Thank you. There's one question. Example is me. I came back from Malaysia in October 2021 with an intention not to work anywhere. I wanted to take a forced retirement, but then destiny has pulled me into this academics again. Yes, please, with administration role. Yeah.
Good afternoon, sir. This question is not for the ice cream. I just wanted to know what is your take on EVs, electronic vehicles? Do you think they will contribute to the sustainable environment or they'll be a dead end?
You are talking about electric vehicles?
Yeah.
Yeah. Electronics is already into the cars. We have all cars fitted with ECUs. Okay, electronics is already in embedded systems, and EV, electric cars, electric vehicles are to be used definitely. And every country is trying to replace the cars run by gasoline or diesel into electric vehicles, okay? And there are many countries which provide even subsidy, okay? In Malaysia, they used to give 5,000 ringgits less if you buy an EV car or a hybrid car. And I think there is a strong push in India. In another 15 years or so, they want to increase the number of electric cars, electric vehicles on the road. Yeah, and of course, there are issues with electric cars like safety at the moment, and safety as well as the battery, how you charge it, how you manage it, how do you replace, and then the battery-induced fires and so on and so forth. And I'm sure you people as researchers will be able to find ways and develop mechanisms by which you can prevent such incidents. Okay, and definitely EV will be the one which you're going to see in next 10 years on the roads so much. Now it's one or two here and there. Yeah. Yes, please. Yeah.
Good afternoon, sir.
Good afternoon.
Sir, my question is about, you talked a lot about success scenarios in predictive models or AI models, right? And you talked about like how it might be the future in 10 years time, everything might be replaced. But there is that safety concern, right? We see AI nowadays on LinkedIn or anywhere, right? Any big platform, that there are AI models that generate false positives or give some random information. It learns from us.
Yes.
Whatever information we put in, it gives results based on that.
Yes.
So how do you maintain that safety parameter when employing these AI models into, we can't give full access, I understand, to the AI model.
Yes,
but
yes,
how
yes.
does that figure in to the equation?
Yeah, it's a good question. When I talked about fault diagnosis, fault detection, fault diagnosis, yes, there are possibilities that you may have false positives. That means it has not actually happened, but your model predicts it's happening. And AIs will have to check that. It's AI sits over these diagnosis models, machine learned models. So AI will have to look at other surroundings, other parameters, and they should be able to detect what is false positive and what is false negative. No, that's actually more skilled people to provide inputs to the AIs. The AI model gets improvised every time you add a new knowledge. Yeah. At the moment, AI is not accepted very much in industries merely because of these false positives. They do not have the confidence in letting a system being run by an AI, and then what happens? Of course, there are a lot of interlocks. No, AIs is not used.
Any predictive models or expert systems like computer gave false positive information?
I'm not aware of any such. Yeah, predictive controllers are working. They are able to control it. The thing is that unlike electrical and electronics engineering, our systems are slow systems. Our time constant is something like, if you go to large processing plants, the time constant is something like 60 minutes to 2 hours. You make a change now and then you want to see 63% of that, it's another 2 hours or so. Slow systems. And our computers are so fast and it's able to see and diagnose whether it is going the right way or not. Yeah.
Good afternoon, sir.
Good afternoon.
Sir, actually recently I went for an internship in SAIL and there I was given the unit of coke oven. So there I saw the coke, the production of coke, and it is being used as a source of fuel in different parts. So instead of coke, can we use something like RDF to create less pollution, as we are talking about sustainability? So
What is that, RDF?
refuse derived fuel.
I am not aware of that.
So the thing is that after collecting the several municipal waste material, and after that, after comparing the different kind of calorific value, so after that we are undergoing the process of pelletization. Then after forming pellets, we can use it as a fuel source in the furnace. So can it be implemented in the industrial purpose? Yeah.
It is being implemented in smaller plants. Okay, of course, the Coke has the highest, the energy density is high.
Yes, sir.
The volume is less, and you have so much of calorific value. But whereas such kind of briquettes that you prepare as low calorific value, that means you need to burn a lot.
So that after studying through this, going through the several research paper, we found that the calorific value of RDF is little bit of lower than the coal. So can it cheaper also? So can it be implemented according to your viewpoint, sir?
Now, as far as I know, there are smaller plants that have implemented such briquettes that comes
mainly
from
the cement
biomass.
industries.
That comes from biomass, but I'm not aware of anything that comes from food waste and all. But
Yes, sir,
definitely
because-
biomass is being used.
Yes, sir, because when I was in internship, I saw that even the coal gas is reused and refined and everything, still there was a lot of pollution. We were not able to breathe in that area properly. There
If-
was a lot of pollution.
If you are in an environment where coal is being used, you can't complain of pollution.
Yes, sir.
Yeah. The morning you go clean, and when in the evening when you come back, you are coated with the carbon
Layer,
deposits.
there's a layer.
Yes.
Thank you,
Layer.
sir.
Yeah, thank you. That's the second ice cream. Prof, don't forget.
Good afternoon, sir.
Good afternoon.
What is your idea about microreactors as they have been implemented in any large-scale industries like that? Like how they can be applied in large-scale industries?
Are you talking about micro reactors or macro reactors?
Microreactors.
Micro reactors.
Yes.
Micro reactors are only used in the experimentation stages where they want to screen catalysts, where they want to optimize operating conditions. They are all done. The high throughput reactors, micro reactors.
Can we use it in large-scale industries? Like, is there any possibilities like we can use?
Maybe someone has to develop a process for that.
Thank you, sir.
Yeah. I've only seen the micro kind of thing. You know cyclones? Cyclones, especially hydrocyclones. Hydrocyclone is one of the smallest equipment handling the largest volume of fluids. Okay? And I've seen a basket of cyclones. That's kind of putting together hundreds of cyclones in one basket and going through that. That's a multiple stage of separations. You can route your fluids in any way you want. Yeah, that's one area. Okay. Okay. How big is that?
We are the world leaders. I come from
Schlumberger. Okay.
Good afternoon, sir.
Good afternoon.
My doubt is that dialysis is such a big equipment, no, sir?
Dialysis.
Is such a big equipment, and we use membrane separations as our chemical engineering part in there. Can't we do a microdialysis with some I have heard from my professor that microdialysis is so I don't know what we'll call that, but is there any possibility to do microdialysis or any nano dialysis for any patient? I have a doubt when my professor arose that doubt for me. So I want to ask you that any suggestion from you or any idea or little advice from you.
Okay. Unfortunately, I'm not working in this area. Okay. It will be very, very tough for me to make a comment. But definitely, the moment you ask me questions, I could think dialysis happens once in 3 days or once in 5 days, depending on the patient's condition. And if you can have a micro dialysis unit attached to your body, maybe it can run continuously without the knowledge of the patient. Maybe someone can think of that. Yeah, but I'm not working in that area. I'm sorry if my answer is wrong.
It's okay, sir. It's
Yeah,
okay.
thank you.
Any more questions? Ice is valid.
We already go to shop or on?
Yeah,
Good afternoon, sir.
good afternoon.
Sir, as we all know, plastics causes pollution to the soil. Okay, so being a chemical engineer, we started on research about bioplastics. We found an interesting topic to make bioplastic from algae like spirulina. So it can be made, but it's not so much cost effective. So what's your suggestion to make it cost effective and to be implemented in industries? Can it be implemented in industry level?
Now, the day plastics are made costlier, okay, people will start using it. It's all relative. Okay, today it is cheap. Today it's very, very costly. The other one is very cheap. You are not able to, people always go for a cheap one. Okay, the moment all our efforts in reducing the usage of plastics, okay, oil or gas-based plastics, start taxing them, then the price will go up, and one day the price will go above the plastics or bioplastics. Okay, so obviously it's only the day. It's, yeah, it's what determines that I should use today is the cost, is the price. If I can get something as a common man, if I can get something at 5 rupees and the other one which is environmental friendly, which is 10 rupees, obviously I will not go for it. I look at that 5 rupees difference.
Thank you, sir.
Taxes should be implemented more in the normal plastics which we use daily.
I think the governments are
take
looking
step
at,
towards this.
yes.
Yes, sir. So, but everyone is not thinking in that way, right? That we should avoid this, we should go for the better one, which causes less pollution and all.
No, they are big players. They will control everything. What you dress, what you eat is everything decided by the big players, not you. You can say one day I will not touch this, I will not do this, and next day you are obviously drawn into that and you are using it without you knowing that. Yes, yes.
Good afternoon, sir.
Good afternoon.
Sir, what is the role of chemical engineers in nuclear industry, sir?
Yes, you have everything to play. Nuclear industry, of course, there are nuclear physics. Okay, the physicists will play a major role. But other than that, there is a process. And chemical engineers are required to design a plant, to operate a plant, everything is by you. Okay? Yeah. Chemical engineers are universal engineers. You are required anywhere and everywhere. Now, at this age, in today's, only you say you are a chemical engineer only until you get your degree. After that, you go into the market, you will be doing all kind of jobs. You have to learn electrical engineering. You have to learn, know some mechanical engineering. You need to know structural engineering and civil engineering. Okay? It's a functional engineer. If you know, you are performing well. If you do not know, you depend on, for this I need to go to a civil engineer, for this I need to go to a mechanical engineer, then you are losing your time, you are losing your value. Okay? Today it's all functional engineers. Okay? And most of us know electronics now. You say we are chemical engineers, you know, most of us, you know electronics. Most of us, we know some AI, some coding, okay, Python, C, at least using MS Excel, PowerPoint, right? It's all, when we studied, there was nothing. Now you have all that. Yeah.
Last row, last question. Yeah, IIT open air there is the SAS code. First week, that is very easy. Next week, what happens, he will come here. This is who. Like that, next year seminar, you have to come here. Okay?
Next, Schemcon, Professor Chidambaram has to go there. The same students will have to come there. The probability is very low.
Any more questions?
So I would like to thank the organizers for giving me this opportunity to be here today. Thank you so much for the Department of Chemical Engineering, Kongu Engineering College. And my thanks to the patient audience. I'm sure I did not introduce much of hard topics here. I actually wanted to go on the surface purposely. I'm sorry if someone has expected something deeper. I'm sorry about that. Thank you for all your time and all those questions. And whoever want to claim chocolate, ice cream. Prof.
Thank you,
Chidambaram
sir.
will be here until tomorrow. You can catch him, no problem. Okay. Thank you and have a good day.
Thank you, sir. Now I request our Dr. M. Chidambaram, sir, to present small memento to Dr. M. Ramasamy, sir. I request all the participants kindly go to their respective venue. Thank you.